Hi, Aaron here, and I wanted to go ahead and talk this time about with the Raspberry Pi Lynx version 2 project about the control section, or the flex circuit as it's called. If you've taken apart your Atari Lynx, you have, in the very top shell here, you have this kind of nylon frame, and it has 6 screws that come out, 1, 2, 3, 4, 5, 6. It's got the speaker and all the controls, so that slides out. I have another one here. I have a lot of Lynx spare parts. I've done a lot of repairs and mods on these things, and I try to save the ones I can, but sometimes things are just like and then we end up making fun things like Raspberry Pis. So this is your control board or your flex circuit, and the flex circuit basically is just this little sheet of plastic that has graphite traces on it that wire up to all these buttons. So when you push one of the buttons on the Lynx, it's making contact. It terminates out into a little flat panel ribbon cable that has 14 pins. And so the first thing you want to do on your Lynx is go to your board and unsolder this right here at the bottom. This is your 14-pin flat panel connector. You want that. You can also buy one of these brand new on DigiKey or something like that. I just reuse these since I'm already using the board for other things. So go ahead and desolder that guy. And then the next thing you want to do is solder wires to pretty much every connector on this thing. And once you're done with that, then you have a nice little custom cable that you can use to attach the controls to the GPIO pins on a Raspberry Pi. And as you can see here, I'm kind of demoing this. I already have one made. So the flex circuit has this connector all wired up. I don't have all the pins wired up, and that's because I was going off of my last project, but I realized I do want to actually use almost all of these. They start with, if you have the notch facing you, and that's the front of the ribbon. So this little notch, it's hard to see it, but there's a notch in the front, and this is the front of the ribbon. The back of the ribbon has like the little white plastic guard. So if you're looking at this from the front, on the bottom right-hand side, that's pin number 1. And then the pin above it is pin 2, then back down is pin 3, back up is 4, 5, 6, 7, 8, all that way. So you end up having 14 pins. Pin number 1 is the ground. Pretty much everything terminates to ground on this board, right? So once you have your ground, any of these other connections are actually just your, for each button. People have asked, hey, can I separate out the two banks? Lynx has A and B buttons top and bottom for ambidextrous players so you can flip it. Can I somehow use these buttons and maybe have A, B, X, and Y? And the answer, unfortunately, is, well, I mean, you probably could. If you modified this flex circuit, you'd probably have to cut the graphite traces. And then, I don't know how you would attach this, but you're probably going to have to lay a wire down and tape it to the graphite and then run your own separate lines for that if you want to do that. That might be something worth pursuing for this version, so I may do that. We'll see. But I don't, unfortunately, they didn't wire it like that. They're just mirrors of each other, so they're wired together. So, going back to the flex circuit here, pin number 14 appears to actually be the LED. In the first version, I never wired up the power LED. This one I'm going to wire up, and you can either take, I think this one will either run this to attach it to one of the wires of the LEDs on the power boost, or one of the wires on, or one of the LEDs on the actual Pi, or we could just put a resistor in line with this and run it right into a 5-volt line on the Pi or the power boost or anything that's turned on when the system's on. It would be really fun if we could have a tricolor LED and somehow break out like the status of the power boost. If it's on, it's low battery, it's charging, etc. But that requires some more logic and things. So maybe someday with a custom board, maybe version 3. The only thing of note is we're going to use all the buttons on this board except the on button, and that's because pin number 9 here is the on button, and just the way that the Lynx is wired, they went ahead and made it to where when you push the on button, you're actually shorting out pins 8 and 9. Pin 8 is the off button, pin 9 is the on button. So when you pressing the on button, you're actually connecting the on and off buttons together. But when you're pressing the off button, you're connecting that one pin 8, the off button pin, to the ground. So that's easy to wire to GPIO. The other one wouldn't be. I might be able to figure out how to use that somewhere else later on with some more logic, but for now, we're not wiring the on button to anything. So we'll use all the other buttons, like the off button we'll tie, and we'll use the off button as an actual shutdown button when we get done with this. So that way when you hold down the off button for like 3 or 4 seconds, the Raspberry Pi will start its shutdown sequence and then turn off. And then all the other buttons you can map to other buttons. Like some people use the 2 option buttons and the pause button and things like that for your X and Y. And then I was using this backlight button on the left and the option 2 button. This is select and then start, which is great. So in Raspberry Pi, in emulation station, sorry, you hold these 2 down and it'll kick you back to your menu. Or you can use it for select and start, which makes sense. So that's the basics of the flex circuit. So now that we're all wired up, we'll go ahead and next we'll connect these to the Pi and solder them. And I'll have to post a link to a chart or something here, basically showing what each pin is and where you want it to go. But I mean, the reality of it is you can pretty much attach these to any of the GPIOs you want to, because really what you're going to do is use some software to map which GPIO pin basically does what. Essentially, what we're doing is we're going to just turn this button pad into a keyboard. So whenever you're pushing a button on here, it's actually going to tell, GPIO pin 15 or whatever it is, arbitrarily, that was, you press the key on the keyboard, label B or X or, apostrophe or whatever you want it to be. And then you map those in emulation station to, you define it as a controller. A fancier way would be to wire these into like one of those teensy microcontrollers and then use that, which might be better and more reprogrammable for later on. But honestly, this thing's going to be enclosed and hardwired. We're not going to mess with it much after we put it together. So that's that. Let's go ahead and wire it up next.